Experiment 5. Determination of acidity of milk titrimetrically. Titrable acidity is of considerable importance as a rapid platform test for rejecting milk unsuitable for evaporated milk manufacture because the developed acidity has much power to lower down the temperature of heat coagulation of casein. Cow milk has titrable acidity varying from 0.13 to 0.14% and buffalo milk varying from 0.14 to 0.15% lactic acid. Casein phosphates, citrates, serum proteins and carbon dioxide contribute 80% of the acidity of milk and the rest 80% is due to secondary changes in titration. Fresh milk, when titrated with alkali using phenolphthalein indicator, shows variation of 0.1 to 0.26% acidity calculated as lactic acid. This is known as apparent or natural acidity, which is due to the presence of proteins and solid salts, particularly phosphates and citrates. The higher the SNF content of milk, the higher is the natural acidity. The real acidity of milk is due to the lactic acid produced by the action of lactic acid organisms in lactose. This is known as developed acidity. Therefore, the titrable acidity of milk is the sum of total of its natural acidity plus developed acidity. Materials: burette of 50 into 1 by 10 ml with soda line guard tube, conical flask, pipette, reagents, standard sodium hydroxide solution of 0.1 normal, phenolphthalein indicator solution of 1%. Principle: the acidity of milk can be determined by titrating the milk against standard sodium hydroxide solution using an indicator like phenolphthalein and is expressed in terms of lactic acid. Though natural acidity in milk is due to its constituents such as casein, albumin, citrates, phosphates and carbon dioxide, but it is customary to express in terms of lactic acid. As 1 gram equivalent weight of an alkali neutralizes 1 gram equivalent weight of an acid, the volume of standard alkali required to neutralize lactic acid of fixed volume of milk gives percent acidity of milk according to the reaction. Phenolphthalein used as an indicator changes from its colorless form at pH 6.5 of milk to pink color form at its endpoint of pH 8.3 and is a fair indicator of acidity of milk. Pink colored endpoint of phenolphthalein is compared with pink color of ricinoline acetate in blank determination. Procedure: rinse the burette with 0.1 normal NaOH. After rinsing, fill the burette with 0.1 normal NaOH with the help of funnel. Adjust the burette reading to 0 mark. Thoroughly mix the sample of milk, avoiding incorporation of air bubbles, and transfer 10 ml with the pipette to each of the 2 conical flasks. Add few drops of phenolphthalein to the other 10 ml of milk. Rapidly add 1 ml of 0.1 normal NaOH solution to milk containing phenolphthalein and continue to add drop by drop until by comparison matches the pink tint of the blank. Note down the reading. Repeat the experiment to get the concurrent values. Observations. Calculations. Percent lactic acid equals to 9 AN upon W, where A stands for burette reading, N stands for normality of NaOH, that is 0.1. W equals to volume upon weight of milk. Conclusions. Acidity of the given sample expressed as percent of lactic acid.